Thanks for introduction. So next, I will talk a bit about artificial intelligence and our software stack, and also the industry use cases using our GPU and our software. So NVIDIA has been a semiconductor company starting with gaming, and then gradually we also start using GPU for high-performance computing and artificial intelligence because these computation, they require large computation resources. And the industry use cases we have has a wide range from computer vision to natural language processing, healthcare, robotics, and special effects in the movies, and so on. So today in my talk, I will have 3 parts. I'll try to keep it short so everyone can go to lunch on time. So firstly, I will have some introduction about artificial intelligence and deep learning. And in the second part, I will talk a bit about NVIDIA's software in AI. And in the last part, I will talk a bit about the NVIDIA program for academia and startups and some industry success stories. So in our daily life, you probably use AI a lot, but not aware of you're actually using it. So for example, when you talk to Siri to ask Siri a question, it actually involves several different stages. So for example, we need to convert the speech into text. This is the first stage. And the second stage, for example, question and answering. For example, if I ask yesterday to Siri, where can I find the restaurants around me? Then Siri recommended me, actually I was in Darling Harbour, and then Siri recommended me like Pancake on the Rock in Darling Harbour. I'm quite satisfied with the answer. So they sometimes could be like recommender systems when you do online shopping, or you try to get some movies to watch, then these recommender systems recommend based on your past behaviors. So a lot of things in our daily life actually involve AI. And in multiple industries, AI can be used in like internet services or online shopping, retailers, security and defense, or medical imaging, autonomous driving, and so on. So for example, in medical imaging, we can use AI to assist the radiologists to analyze the MRI or CT scan to identify the tumors and so on. And also like in the pandemic, we can try to apply AI to deliver some, for example, use robots to deliver the groceries in the lockdown, or in smart hospitals, they're trying to develop some contactless system for the doctors to assist the patients remotely. Or, for example, in security and defense, we could do intelligent video analysis, IVA, to ask AI to do the job like analyze the video to find the suspicious behavior instead of asking human to stare at the screen for 24 hours, 7 days. So you probably hear deep learning a lot. So what is the difference between deep learning, machine learning, and AI? So AI is a more broad concept that applies to the techniques requires the human level intelligence and use machines to do that. So this is more broad, and machine learning is one approach in AI that is based on statistics, and usually this requires human experts to extract features from certain domains. I'll show some examples in the next slides. And deep learning is one type of machine learning that use deep neural network. So, for example, sorry, I don't know what's going on. I don't show anything. Okay. So, for example, we try to identify the car in the picture, and using traditional machine learning method, we need to ask the experts to describe the features of a car. For example, a car has 4 wheels, and so on. But in deep learning approach, we use a lot of image of cars to train the neural network to identify the car. So the difference is when you have a lot of images, some images have, they are taken from different positions. And for example, in this picture, we don't actually show 4 wheels of this car. And the feature extraction based on 4 wheels, that means a car might not work here. But for deep learning approach, because we feed this neural network with a lot of images, and these images are taken from different angles, some are blurry, some are clear, and the neural network can be trained to be smart enough to identify this is a car. So let's further have a look at deep learning. So what is deep learning? Deep learning is based on this deep neural network, which is, oh, sorry, not sure why this connection has a bit problem. Or maybe it's because this is off. It's on my screen, but it's not it.
Oh.
Oh, okay. Thanks. Okay, so in this neural network, we have several layers, and we use this, each element to simulate a neuron in the human brain. So we do this type of matrix multiplication to, so the calculation is actually like weighted sum, which is a bit similar to the computation in high-performance computing. So in this neural network, the earlier layers, like the first 5 layers, they are doing convolution neural network. So each element is calculated based on a 3x3 convolution from the last layer. And the earlier layers, they are responsive to lower level features. For example, for this face recognition, the lower levels responds to the lines, the textures, and then the later layers responds to like the eyes, nose, and then the later layers responds to like the human face. And because the calculation behind this is actually the matrix multiplication, and that means that there are a lot of parallel computing behind it. That's why the GPU is a good hardware platform to do this parallel computing to make it faster. So another example, this is about deep learning. It has 2 stages. So one stage is a training. This is the first stage to use a large amount of data to train your network to be smart enough. So for example, I have a data set with different things. So this is an example of supervised learning, which means each data has a label, like each image has a label of tree or cat or dog. And then I train this neural network for many iterations. For example, at the beginning, it might be very inaccurate. So it mistook this image of a dog for a turtle. So this feedback is provided in the back-forward propagation to improve the accuracy of the neural network. And after several iterations, the network is trained to be smart enough to be able to identify this is an image of a dog. So we do this training maybe many hours or maybe many days on GPU. So this is not a difficult task. This could be done in very short time, but for like natural language processing, it could be require a long time to actually train the model. It could be several days. And we get the trained model. This is the time we can use the trained model for inference. So for inference, we give this network a different image that is new to the network, but because it's trained to be smart enough, and it can identify the new image to identify it's actually a cat. So this is actually inspired by the human's learning behavior. For example, if there's a baby or a toddler, you teach them how to identify the objects. Usually after you show them a few pictures, they kind of learned what these objects are. So this is how we try to use the neural network to simulate how human can identify the objects. And the reason that the deep learning topics are so popular is because these days we have a large amount of data from like the internet, from the security camera, from like audio, call center, and so on. This large amount of data is required to train the neural network to be smart enough. But of course, I think these days they also some researchers try to research on how to train the neural network with a small data set, because it's not easy to get large amount of data in certain areas. And also another important reason is about we have the hardware has been developing very fast these days. So we have these like GPU, TPU, and other platforms that is good for accelerating these type of parallel computing. Sorry, why this is always disconnected? Okay, so 3 important areas in computer vision include image classification, for example, identify the category of the image, or object detection to detect what is in this bounding box. This is particularly useful in like autonomous driving or face recognition and so on. And also like image segmentation, which could be using medical imaging. So, I think, is that almost the time? Okay, I'll be very fast. NVIDIA is a hardware company, but we also have software teams to develop the software for customers to run on the GPU platform. We have different software. Actually, this is only about AI, but we also have software in high-performance computing, in visualization, like Universe. I work on AI related. So this is the several category in AI. And yeah, I think I'm running out of time. But in the end, we will upload the slides, right? So yeah, I still have a few. OK, sorry, just one more. Let me quick share, because Thomas told me this is important to share. Let me skip these things and just share you 2 important things in the end. OK, so we have one program. This is for academia, for researchers to apply the GPU hardware. This is running at certain time in a year, so if you're interested, you can apply for this one. The second program is actually for startups. This is for like global network of startups. Now we have like more than 10,000 for you to be able to connect with experts, to access the hardware, access our free training like a deep learning institution, and also help you connect with the investors and help you to do marketing for your products. So these are 2 things that I want to say in the end.
Beautiful.
Thanks.